Have you ever wondered what it takes to change the world? To discover something so fundamental that it rewrites the rules of science and opens up entirely new fields of medicine and technology? Today, we're diving into the incredible life of a woman who did just that, not once, but twice. This is the story of Marie Curie, a name synonymous with genius, perseverance, and radioactivity. Born Maria Skłodowska in Warsaw, Poland, in 1867, she grew up in a world where opportunities for women, especially in science, were almost non-existent. Her family, though intellectually rich, faced financial hardship and political oppression under Russian rule. From a young age, Maria was brilliant, with an insatiable curiosity and a hunger for knowledge that could not be contained by the limitations placed upon her. She dreamed of studying at the Sorbonne in Paris, the epicenter of scientific learning, but her family couldn't afford it. So, what did she do? She made a pact with her sister Bronislawa. Maria would work as a governess to support Bronislawa's medical studies in Paris, and once Bronislawa was established, she would, in turn, support Maria. For years, Maria toiled, saving every penny, all while secretly studying mathematics and physics in her spare time. She attended a clandestine flying university, an underground educational network that defied the Russian ban on higher education for women. This period of her life was a testament to her iron will and unwavering determination. Finally, at the age of 24, her dream came true. Maria moved to Paris, enrolled at the Sorbonne, and officially became Marie. Life in Paris was tough. She lived in a drafty attic garret, often surviving on little more than bread and tea, sometimes fainting from hunger. But her passion for learning burned brighter than any hardship. She immersed herself in her studies, graduating first in her class in physics in 1893 and second in mathematics the following year. It was around this time that she was looking for lab space to conduct her own research. A colleague introduced her to a brilliant, yet shy, scientist named Pierre Curie. They quickly bonded over their shared love for science. Pierre was captivated by Marie's intellect and dedication. He wrote to her, "It would be a beautiful thing to pass through life together, hypnotized in our dreams. Your dream for your country, our dream for humanity, our dream for science." In 1895, they married, forming not just a loving partnership, but one of the greatest scientific collaborations in history. Marie was looking for a topic for her doctoral thesis. She was intrigued by the recent discovery by Henri Becquerel, who found that uranium salts emitted mysterious rays, similar to X-rays. While others moved on, Marie decided to investigate these uranium rays more deeply. This was a pivotal decision. Using an electrometer, an ingenious device developed by Pierre and his brother, she began meticulously measuring the faint electrical currents produced by these rays. Her systematic investigation led to a groundbreaking discovery. She found that the intensity of the radiation depended only on the amount of uranium present, not its chemical form. This suggested that the radiation was coming from the atom itself, a radical idea at the time when atoms were thought to be indivisible and unchangeable. She had just laid the foundation for atomic physics, but she didn't stop there. While testing various minerals, she found that a sample of pitchblende, a uranium-rich ore, was far more radioactive than pure uranium. The only logical conclusion was that there must be another, unknown element in the pitchblende, one that was incredibly radioactive. Pierre, seeing the profound importance of her work, abandoned his own research to join her quest. What followed was an epic feat of scientific detective work and sheer physical labor. They obtained tons of pitchblende waste from a mine in Bohemia. They set up their laboratory in a leaky, drafty shed next to their school place, a fellow chemist described as a cross between a stable and a potato cellar. For 4 long years, they worked tirelessly in this miserable shed. Marie, stirring huge cauldrons of boiling, bubbling pitch, blend with a heavy iron rod, nearly as tall as herself, painstakingly separating the material into its chemical components. It was grueling, backbreaking work. Their perseverance paid off. In July 1898, they announced the discovery of a new element, which Marie named polonium in honor of her beloved homeland, Poland. But they knew there was another, even more powerful element still hiding in the pitchblende. Just a few months later, in December 1898, they announced the discovery of a second element. They called it radium, from the Latin word radius, meaning ray. They had also coined a new term for this strange new phenomenon, radioactivity. In 1903, Marie Curie became the first woman in France to earn a doctorate in science. That same year, the Nobel Prize in Physics was awarded to Henri Becquerel and Pierre Curie for their work on radiation. Initially, the committee had intended to exclude Marie from the prize, a glaring example of the sexism of the era. But Pierre, a true partner in every sense, insisted that he would not accept the award unless Marie was also recognized for her foundational contributions. The committee relented, and Marie Curie became the first woman ever to win a Nobel Prize. Their fame brought new challenges, but their passion for science remained. They chose not to patent their radium isolation process, wanting it to be freely available for further scientific research. They believed their discoveries belonged to the world. Tragically, their shared dream was cut short in 1906. Pierre was killed in a street accident, struck by a horse-drawn carriage. Marie was utterly devastated. She lost her husband, her closest friend, and her scientific partner. The Sorbonne offered her Pierre's professorship, a position she accepted, becoming the first female professor in the university's 650-year history. She poured her grief into her work, determined to continue the scientific legacy they had built together. She dedicated herself to isolating pure radium metal and establishing an international standard for measuring its emissions. Her work was so precise and definitive that the unit for radioactivity, the Curie, was named in their honor. In 1911, Marie Curie achieved something unprecedented. She was awarded a second Nobel Prize, this time in chemistry, for her discovery of polonium and radium and the isolation of pure radium. To this day, she remains the only person, man or woman, to have won Nobel Prizes in two different scientific fields. But her work wasn't confined to the lab. When World War I broke out, Marie saw an immediate practical application for her discoveries. She knew that X-rays could help surgeons locate shrapnel in wounded soldiers. She developed mobile radiography units, which became known as petites curies or little curies. She equipped vehicles with X-ray equipment and power supplies. And with her teenage daughter Iran, she drove to the front lines, teaching military doctors how to use the technology. It's estimated that her mobile units treated over 1 million soldiers, saving countless lives and limbs. After the war, she continued her work establishing the Radium Institute in Paris, which became a world-leading center for the study of radioactivity and its medical applications. She also traveled to the United States to raise funds for her research, becoming a global icon for science and progress. However, a lifetime of handling radioactive materials without understanding the dangers took a heavy toll. Marie Curie suffered from various health problems, and in 1934, at the age of 66, she passed away from aplastic anemia, a condition now known to be caused by prolonged exposure to radiation. The notebooks she used in her research are still so radioactive today that they are stored in LD-lined boxes and can only be handled with protective clothing. Marie Curie's legacy is immeasurable. She not only discovered 2 new elements and founded the science of radioactivity, but she also shattered barriers for women in science and inspired generations of researchers. Her work paved the way for nuclear physics, cancer treatments like radiotherapy, and countless other technologies that shape our modern world. She was a true pioneer, a relentless scientist, and a profound humanitarian. Her life story is a powerful reminder that with curiosity, courage, and an unbreakable spirit, one person can truly illuminate the world. Thank you so much for watching. If you were inspired by Marie Curie's story, please hit that like button and subscribe for more journeys into the lives of incredible people. See you next time.